Okay, this is Dr. Morton giving you hopefully a short video here. I'll get it uploaded in just a minute. This is for the practicum for tomorrow, Tuesday. What is it? The 25th of March. Okay, and what this involves is using an OLED display. So let me show you this. Hang on one second. Okay, so here's what this should look like. So this is the Beaver board, and what I have here is an OLED display, and this has ground, power, SCL, and SDA, and we have this marked exactly the same way. Now you can't plug it in here because this one is set up. I don't know if you can see that or not, but this one is set up. Yeah, it's hard to see. Oh. This plug is set up ground, power, SDA, SCL. So the clock and the data lines for the I2C are reversed. And so that's why we have two different connectors. So we can plug the 2-line-by-16 display in here, and it'll work great. And we can plug the OLED display in here, and it'll work great. And I'm going to turn off the light so we don't blind us. And then if we hit reset, what it's supposed to look like, you'll see the splash screen come on, and then what you'll see is it'll put my name up. I don't know if you can read that. It's kind of funny how that works out. It's just, we just need a little bit less, or maybe, I don't know. Yeah, it doesn't matter. But anyway, and then you see, and then it has this pot thing where if we turn the potentiometer, we'll change the numbers on the pot. So it's full clock. I'm turning it counterclockwise now. The numbers are going down. And finally, we'll go, well, and then now they'll go to 1, or well, 4, 19, 20, 69, and so forth, and all the way up to 1023. Okay, so anyway, so that's what that looks like. Okay, so let me explain how this is going to work. Okay, so if you look at the program, so the first thing you do is you create the program, and so I already did it here, Practicum S25, and then you're going to go down and you're going to right click on source, and you're going to do new source main C, and then once you do that, you're going to call it Practicum S25, and then you're going to paste in the starter code. Okay. Now, a couple of things about this. Notice the starter code includes this splash screen here, and the actual amount of information on the. Let's see. I'm sorry, I went through that. Yeah. So this is actually the splash screen here. It's exactly 1K of data, because if you do the math, the splash screen is exactly 128 pixels by 64, and if you do the math, okay, so if you get the calculator out and you type in 128 times 64, you get 8,192 pixels. If you divide that by 8 to get the number of bytes, it's exactly 1K bytes. Well, the entire RAM memory on the PIC is 1K of RAM. So you can't put the splash screen in RAM. So where can you put it? Well, it turns out we have 8K of program memory, and you can, even though each program memory location is 14 bits, you're allowed to use 8 of those bits as data, as constant data, if you want. So what we do is we declare this splash screen here as bitbucket.org. Anyway, this is where I did it, and so constant character SSD font 8 by 16 blah blah blah. And actually, this is a big font, so this isn't even the right thing. That's the so where's my splash screen? Good Lord, it's here. Sorry, my splash screen is here. Here's the splash screen. So it's logo, and it's 1024 bits. It's 100. It's 1024 bytes, and here are the bytes. And I created this with a special program that allows you to do a drawing and convert it to a fixed size in bytes and format it for that display. And so here are all the things everywhere. This is so 1K of bytes, and the 1K of bytes defines that 8K of pixels. And a 1 turns it on and a 0 turns it off, I think. And so anyway, I write out the splash screen by, what did I call it again? I called it logo. I put it in an array, and because I declared it as a constant, that put it in program memory instead of RAM. Okay, so anyway, when I actually did the splash screen, so all I basically did is I did the pin and clock config, A to D init, I2C init, and the SSD 1306 init. That's the OLED display. And then I said clear the display, so write all zeros, and then write logo, so that's an image. So it writes that image into the display, all 1K points. And the first is the image, and the second is 0 dark background, 1 light background. And so I made it a light background. And then I wait 2 seconds, and then I'm going to erase it, and then I'm going to write my name, Paul Morton, and I think I'm going to change this to a light background so you can read it. And then you wait 2 seconds, and then you start counting I equal 0 to 11 or something like that. And then then after that, we go into an infinite while loop, and we read the pot with the get A to Z result, and we convert that to a field called in this array called sout. And in that field, we have this format instruction, which is pot equals %d in quotation marks, comma pot. So that's using sprintf, and it's going to put that string in sout, and then here we're going to write that string out using the 16 pixel characters, and these other configurations basically state where we're going to start writing these characters, and then we write them across the screen. So we're going to go down 6 lines from the top, start in position 0, and we're going to output sout with a dark background, or the light background rather. And so let's see what that looks like again. We'll compile this again, and then I'll run it one more time. We'll transition back over here, and so okay, so there's the splash screen, and then there's my name written where I think you can see it now. Oh crap, it's not. Okay, so we're going again. So let me reset it, and then you'll see the splash screen, and then it'll print out my name. And then it's going to start doing the counting to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so these characters are smaller than the other ones. So I wrote my name in the larger characters, and then the pots in the larger characters, but I did that counting in the smaller characters. And all right, and then you can see as I change the pot, I'm reading the pot and I'm putting that number out. It goes up to 1023, and it goes all the way down to all the way down to 1, like that. All right, so that's what it looks like, and that's what your program needs to look like to get it working. Okay. So back to the program. So here's what I want you to understand. So you're going to load into the you can call it Practicum. So you're going to create a project. and you can call it Practicum S25. And then you're going to load in the source file. You're going to right-click, New, Main C, and then you're going to load in the starter code. And then here's the important part that I'm trying to make sure you understand. If you go into the header file, so you click on the header file, you right-click on that, you hit New, and you go down to xe8_header.h. And when you do that, it'll create this header, and then you give it in this case, I'm going to give it a bogus name. But the first one you want to put in I2C, and then the .h is automatically appended here, okay? And then you hit Finish, and so then it's going to create this shell. Now notice this shell's got it's got a disclaimer up here. It's got file, author, comments, revision history, so you can fill that out if you wanted, but don't. Just leave it blank. And then basically, we're just going to completely delete this. We're going to take all this out. Okay. And then we're just going to paste one of the other headers over this. I think this is the SSD 1306 header. And so now it's got this, and it has, the interesting thing is, so it's got a bunch of function calls you can do, and these are the function definitions, and then are the prototypes, and then the I2C prototypes, and some of these other things. Okay, now I want to point out three things. One, this is a graphical display. So you can't just send it an ASCII character and expect it to display something. It won't. It'll treat those as 8 pixel bits, and it'll put them some arbitrary place or something, depending on how whatever function you use to send it to it. Notice you have init, command, data, character, character 8, character 16, graph, out 8, out 16, set cursor, set contrast. And so these are a bunch of things. This doesn't have any graphical characters. Maybe someday I'll set that up. And basically, you have row and column. And I think there's 16 rows and maybe 32 columns or something like that. That's not too many. And when you want to put a character there, it uses, in this case, I think it uses an 8 by 16 pixels to make a character. This set of characters down here uses 8 by 8, so they're half as big. And then I started to create some graphic stuff, but I don't have this finished, and so one of these days I'll finish this up. But this will let you do a little bit of graphic stuff. Okay, so you have two choices of fonts for your characters, and you have one splash screen that's stored in your main code. The splash screen winds up in program memory, and so do these wind up in program memory, because we don't have enough room for this stuff. Now notice the big characters, this first line is 0, the next line is the exclamation point, double quotation, pound, dollar, percent, ampersand, tick, left paren, right paren, and so forth. All the numbers, and then uppercase, lowercase, and a few other special characters. All right, and then the 8 one, they didn't bother to put the characters in. But all you have to do is you can when you put in the when you write these. So let's look and see how this writes. If I go into our code, so all I have to do is write percent double quotation mark I equals percent D, and then comma I. So that's going to put the number in for D, and then it's going to store this character string in S out. And then when you print this, you do SSD 1306 underscore out 8, so using the smaller character set. And you start at line 6, row 6, line 0, column 0, row 6, column 0. There's the string, and you want the light back or the dark background. And boom, it'll write that. And when it gets, since it stores this character string with a null character for the terminator, once it gets to the null, it stops. And then here's where it reads the pot. Notice the pot, it uses the SSD out 16, so those are the bigger characters. They're a little easier to read. And again, we start at line 4, for Paul Morton, we start at line 2, position 2, and we write Paul Morton. And here we start line 6, position 0, and we write the S out 1. And the S out again is going to be pot equals %D. And then how do we get the pot? We use pot equals get A to D result. And so it automatically reads the pot and assigns it to pot. And then this takes the actual number for pot and puts it in as a decimal, and pot equals that decimal. And I think we should put an extra space in here to fix some of the goof up. Anyway, something like that. All right, so that's kind of what we got. And let me just make sure this works correctly. And so, yeah, we'll go back and do this. Yeah, I just want to make sure when it runs. There's the splash screen, and then we'll see it does my name, and then it should do that little I. It'll count to 11. You can probably see that barely. Oh, never mind. Okay, now I'm going to punch it again, and you'll see the splash screen. There it is, and then you'll see my name in the 16 by 16 characters, and then you'll see the little I counting from 0 to 11, or maybe 10, I guess, in the 8 by 8 characters, and then you'll switch back to the 16 by 16 pot equals 1, and then if you turn this should go all the way up to 1023 rather, and then it should go back down to 1. Yeah, it does, and it doesn't leave any digits. That's perfect. Okay, so you see, that's it, and that works fine. And okay, so let's do. All right, so here's the main thing I want you to get. I want you to get the way you have to create these header files is you have to go in here and click on the header files. That's and I see this one. I need to delete this one because I didn't really want this one in there. Yeah, cut. Yeah, remove from project. Okay. And all right. So then, so you have to create these, and you do that by right-clicking on header, going over xc8.h, and then you type in the right name. When you type in that name, remember, don't change this box here. That screws everything up. Just type in I2C for the first one, and then type in SSD 1306 for the other one. It will automatically append the .h, and everything will be fine. Okay, and then when you get that in there, erase the guard stuff and all the other stuff, and just paste in the files that you download. And remember, when you go into here, you have to download I2C.h and you have to download SSD 1306.h, and put those in Notepad or maybe WordPad, but probably better to avoid Word because it can put in some formatting characters that can screw things up. So, and I just downloaded them into WordPad, and then I copied them and I pasted them in. And I had I2C and then SSD 1306.h. You have to use the right names because that's how they're referenced in the starter code. And you can see I did the includes up here in the main code, so they're right here. Include I2C.h and include SSD 1306.h. And that's all you have to do to get this to work. And the complete instructions then will be set up in this Practicum folder, which I'll change that to S25, and I'll have the instructions here, and I'll tell you exactly what I want you to do. All right? Okay, so just follow that, and I do want 3 people in every group as much as possible, and if obviously we could even have 4 people in a group, but I don't want, I'd like to have 3 or 4 in every group. But probably 3 is better. I think most of the groups are 3. I think that's what I said. So I'll fix that. So 3 in a group, maybe a group of 2 because it may come out odd, or if it does, we'll have 2 groups of 2 or something. All right, that's it. I'm going to end this so that we'll be done.